Hey guys, today we're going to be having a look at sequences. We did a few sequences in the camp, but we didn't go into it in much detail. So I've got a couple of examples up here, and we're going to go look at them. I know some of you did some of these examples or something similar using induction, which is great. Like, that's awesome that you use that technique, and now you're feeling more confident with it. We're going to try something a little bit different. We're going to try and use some of the sequences that you already know, the arithmetic sequence and the geometric sequence, and try and make a manipulation of them. The sequences are often also called recurrence relations because they're a relationship between one term and the next, and they're recurring. So if you see that word, you know what that means now. So we know the formula for the standard geometric sequence, which is that if you have the first term u1 and you have the ratio r, then each term is just the ratio times the next, then the relationship is just the first one times the ratio to the power of n minus 1 to get your nth term. So we're going to try and use that relationship to solve these questions, which can't already be used like that because it's both a constant term as well as a ratio. So we're going to see what we can do here. So now un plus 1, we know now is equal to 2 un plus 1. And now we'd like this side to be some sort of a multiple of this side. So what I'm going to do is just add simply 1 to both sides. So un plus 1 plus 1. Then it's just 2un plus 2, right? And then I'm just going to factorize this to be 2un plus 1. Now this looks a lot like a geometric sequence, right? Because you have a term, which is un plus 1, and then an extra plus 1, and then another term, but then the whole thing is multiplied by 2. So to make it formal, what we're going to do is we're going to set vn equals un plus 1 for all n. Now this also means that vn plus 1 equals un plus 1, and also means that v1 equals u1 plus 1, and u1 we said was 1, so that's just equal to 2. So now, using this equation, we have that vn plus 1 now equals 2vn. And so that's just a geometric sequence now, which you know how to write this solution for. So that's just vn in general equals v1, which is 2, times the ratio, which is also 2, to the power of n minus 1, which is then just 2 to the n. Nice, right? And then we just plug that back into un. And so we know that un is just equal to vn minus 1, which is then just 2 to the n minus 1. And there you go, you have your proof. Not too bad, right? So now we're going to try and apply the same thing for the next one, and we find that it won't work as easily as the previous one. So we'll try the same thing. So we have now that un plus 1 equals 3un plus 1. Now you might think we should add 2 to both sides, because if we add 2 then we just get this plus 3 again as we thought. So if un plus 1 plus 2 equals 3un plus 3, which is just 3un plus 1. The problem here is that we have a plus 1 on this side and a plus 2 on this side. So it's not quite what we want. So what I'm going to instead try is I'm not going to decide what I'm going to add to both sides. I'm just going to let it be some number x. So un plus 1 plus x then equals 3un plus 1 plus x, which is then just 3un plus 1 plus x over 3. Now I want these two values to be the same, so that I can apply the exact same process again, which was to, let me just make sure this is still recording. Yeah, so this is just going to add both sides. So then I just want x to equal 1 plus x over 3. So then I simplify that to 3x equals 1 plus x, which then for me implies that 2x equals 1, or x equals 0.5. So that was the key number that I needed to add to both sides. So let's just go back and add that again. So what I find is if I add 0.5 to both sides, I get that un plus 1 plus 0.5 equals 3un plus 1.5, which is just the same as 3un plus 0.5. Now if I again set that vn equals un plus 0.5, I get that Vn plus 1 equals 3 Vn, and V1 equals 5 plus 0.5 equals just 11 over 2. So then the general form for Vn is just 11 over 2 times 3 to the n minus 1. And then I just find un again, so now un equals 11 over 2 times 3 to the n minus 1. Since I added 0.5, I now just need to subtract 0.5. And voila, I have my solution. So now there you go, you've got the general way of doing this sort of question. Just play around with it, plug in some values. Try un plus 1 equals 7 un plus 5. Try 3 un plus 6. You know, just put in some different values, start with some different starting points, and get comfortable with it when you can. Right, see you next time.